Okay, welcome to Trig Chapter 5.4, Part 2, where we're going to do some verifications on half-angle identities. I will be doing just 3 identities, so this video should not take very long. The first one I'm going to verify is cosine squared of x over 2 minus sine squared of x over 2 and prove that it's equal to cosine of x. Well, I look at this and it looks very similar to an identity we already know. And that is one of our double angle identities. The double angle and identity that it looks like to me is cosine of 2x, which is equal to cosine squared x minus sine squared x. So I'm going to use that concept right there. And I am going to look at this x over 2 as simply my angle. That is my angle, x. What I mean by that is I am simply going to substitute my cosine of 2x for this and call this cosine of 2 times x over 2 and write my equal sign. When I do that, all I did was substitute x over 2 for my x. The 2's will cancel out because it becomes a fancy form of 1, and I end up with cosine of x is equal to cosine of x. Yes, this verification was that easy. Well, let's do another one. Okay, now I'm looking at this one, and it looks very similar to the one that I just did. Meaning that if I just look at this and I don't look at the x over 2, but I just look at that as just an angle. For example, if I have 2 of sine, I'm going to call it alpha, cosine of alpha. That looks exactly like one of my double angle identities, and that happens to equal sine of 2 alpha, or 2x. So I am going to do exactly what I did with the previous verification, and I'm simply going to substitute sine of 2x for this. 2, oops, let me erase that. I didn't want the sign, I want that there. I'm simply going to write sine of 2 times my angle measure, which happens to be x over 2. Write my equal sign. Simplify things in parentheses. 2 times x over 2. So it becomes sine of x. Those 2's cancel out. And I finish that verification. I'm going to do one more. This one's a little bit more difficult, but not that difficult. And here it is. Okay, there's a lot going on with this one, or so it appears from the outset. I have cosine squared x times tangent x minus secant x times tangent x plus secant x equals sine squared x minus 1. So I need to prove that these two things are equal to each other. And I'm going to work with the left side because it is more complicated. And the first thing I'm going to do is to FOIL the things in parentheses. They look like conjugates to me, which means that I would simply write tangent squared x minus secant squared x. If I FOILed those, that's what I would get. Bring the cosine squared x along. Let's see, I'm trying to get the sine squared x minus 1, so I'm going to change tangent and secant to something with sine and cosine in it. Tangent squared x is equal to sine squared x over cosine squared x. Secant squared x is equal to 1 over cosine squared x. And I'm just going to bring cosine squared x along. I'm going to write this as one fraction. I've got sine squared x minus 1 all over cosine squared x. That's times cosine squared x. And I think we've done it. Because I do the multiplication, cosine squared x times the things in parentheses, these cosine squared x's will cancel out. And I have sine squared x minus 1 is equal to sine squared x minus 1. And we finished this, and this is the end of our video. See you in class.